I'm sure that, like me, you've seen a whole bunch of stuff in the media lately about artificial intelligence. AI as an investment opportunity, AI as a threat to the climate, and of course, a whole array of advertisements for new AI-powered products. Just the other day, I saw an ad for something that they were calling a bespoke AI-powered washing machine. I'm a philosopher, and so you can relax. I don't have any washing machines to sell you. What I'm interested in is the underlying nature of human language and thought. And so I would like to try to cast light on a different dimension of AI. AI as a kind of a mirror that we can hold up to ourselves to discover more about our own minds. And today I'd like to focus on the big picture, how exactly this research works. So please allow me to explain. Us humans are capable of some truly incredible, and until recently, totally unique things. We can think and reason and make art, and we can make art about thinking and reasoning. And of course, we can also communicate through spoken and written language. I think it's easy to take this last ability for granted, because it's something that most of us master as small children. But if you stop and think about it, it's really quite an incredible thing. Right now, I'm standing here using my vocal cords and articulators to emit a specific set of sound waves, which are physical things, that are traveling through the air until they reach your inner ear, at which point they are transmuted into electrochemical signals propagating through your brain. And somehow that process allows me to transmit the thought that I have in mind right into your head. How is this magic trick possible? And, in keeping with our big picture question, how can we find out? For most of human history, the dominant method has been introspection. So here's a quote from the famous American philosopher and psychologist William James. James says, "Introspective observation is what we have to rely on first and foremost and always." The word introspection need hardly be defined. It means, of course, the looking into our own minds and reporting what we there discover. Everyone agrees that what we there discover are states of consciousness. Now, introspection is a powerful tool, but there are two big problems with it from a philosophical or a scientific perspective. First, it's fundamentally subjective. What this means is there's no external way to verify if and when introspection is reliable. That's one problem. A much deeper limitation comes from the fact that introspection is really only a way of exploring the contours of our conscious minds. But lots of what matters goes on beneath the threshold of consciousness. I think our sort of popular idea of the unconscious comes largely from Sigmund Freud, where it exists as a kind of a repository for suppressed memories and desires and things like that. But it's fair to say that the contemporary consensus is that the unconscious plays a much larger role in our mental lives. So for example, if I was to take off my glasses and try to toss them to someone in the crowd, that would require an extremely complex array of subconscious computations. My visual system would need to estimate the difference in the angle from me to the person I was passing them to. And then my motor system would have to coordinate with that, right? And would have to figure out how much force and in what array to move my muscles. This kind of unconscious processing plays a crucial role in language as well. So think about the simple case of ambiguity. Think about a sentence like the following. Try on the red dress in the window. I think that the natural way to hear that sentence is probably to hear the phrase in the window as modifying the location of the red dress, right? Try on the red dress. Which one? Oh, the one that's in the window. But of course, we could use that very same sentence to mean something quite different, right? Means to try on the red dress. Where should I try it on? Oh, I should try it on in the window. Completely different meaning, and if you get it wrong, you might have an issue. This is the important factor here, though. Sometimes, maybe when we're reading poetry or really stopping to reflect, we might focus on this kind of ambiguity and interpretation consciously. But most of the time, our minds resolve this kind of ambiguity before the sentence ever makes it to the surface of consciousness, and we just hear it one definitive way. How does this work? In this kind of a case, we can't rely on introspection because it's an unconscious process. So we have to use a different method, a method called inference to the best explanation. To explain this method, think of analogy with a different field, namely archaeology. Let's say that what I want to understand is what life was like in ancient Pompeii. Well, unless someone has invented a time machine that I don't know about, there's no way for me to directly observe this. But that doesn't mean there's no way for me to figure it out at all. by using a more sort of indirect method, I can still piece this together. So for example, if I notice that on some of the streets that we've excavated, there are grooves worn into the cobblestones about, let's say, 3 feet apart, running in parallel lines, I might well infer that this was a road that wagons and carriages and carts went down. And I might think that that means that it's a sort of an important street, a thoroughfare. And that might allow me to infer something about the buildings that it's connecting, that they were an important part of the life of the city. And in this kind of way, using this sort of Sherlock Holmes inference method, I can begin to piece together a certain kind of understanding, even of something that's beyond my direct access. This method, inference the best explanation, is a crucial part of the methodology of cognitive science as well. Even if we can't directly observe every aspect of our minds, right? We can still figure out what it is that's going on beneath the surface by examining the traces that the mind leaves in our sort of behavior and in our brains. That is inference the best explanation. We develop different hypotheses, and because this is a science rather than history, we can also devise experiments that help us distinguish between competing theories and competing hypotheses. That is how we make progress in this field. So that's the big picture. And now here is where AI comes in. Over the course of the 20th century and into the modern day, one particular philosophical hypothesis has really won out or risen to the fore. And that is that the best way to explain human intelligence is by understanding the mind and the brain as forming a specific kind of computer. The mind is essentially the software that is running on the hardware of our brains. That's one way to think about what linguistics and cognitive psychology are up to. They're trying to characterize the software of the mind. This has proved to be an extremely powerful explanatory strategy. So let's consider, again, ambiguity. From this kind of an understanding, structures like these, which are called parse trees, these are not merely the kind of thing that you would find in a linguist's textbook. The idea is these are the kinds of structures that we have in our minds. When we hear the English sentence, we represent multiple possible interpretations with this kind of dependent structure, and then by using context clues, like, for example, whether there really is a red dress in the window, or whether this photographer is the kind of person who thinks that I want to go have my photo taken in a red dress in the window, we settle on one meaning or another. That's the explanatory structure. But the big question is this. What does it mean to say we have parse trees or dependence relations or symbols in our brains? How is it that the neural network that we have running between our ears can realize and instantiate this kind of structure? That is precisely the kind of question that contemporary AI can help us to answer. Today's most powerful AI systems are artificial neural networks, essentially very large collections of very simple units that function like the kinds of biological neurons that we have in our brains, and which taken together in aggregate are capable of all sorts of extremely impressive things. For example, AI systems really do not struggle at all with the kind of semantic ambiguity that we've been talking about. Here's the amazing thing. In many cases, computer scientists and people working in this interdisciplinary artificial intelligence-based area have succeeded in interpreting the internal workings of these networks and found structures very much like this. In some cases, it seems like these artificial intelligence systems are achieving human-like behavior and capacities on a similar underlying basis from what cognitive scientists have been hypothesizing. This is like really quite an amazing thing and may well help us to take a step forward in understanding how it is that this kind of software, or mindware as it's sometimes called, is realized in our brains. That would already be a major advance, but that's not all. Because sometimes when we hold this sort of mirror of AI up to ourselves, what we see is in fact not what we expect, right? In some cases, interpretation has revealed structures much like those that psychologists have posited. In other cases, however, these AI systems seem to have hit upon novel, very surprising solutions to familiar problems. So here's how this field of research works. We take artificial neural networks and we train them and build them to do specific things that we're interested in understanding. These networks, by the way, do not need to be the extremely large neural networks that have these extremely large environmental effects. We can use much smaller models for this kind of research in many cases. But we build these models that can do these things, And we use our interpretive methods to understand how it is that they're attaining this, right? We build hypotheses and theories to understand their inner workings. Then we take those theories and we compare those to our best theories of human behavior. If those theories align, now we have some compelling confirmatory evidence that we've been on the right track all along as cognitive scientists. But when they diverge, what this means is we have a new candidate hypothesis or a new theory, not only about AI, but about how it is that we're doing this. You might think, why is that the case? Why doesn't this just show that AI and humans are different? That is, of course, a live possibility. But remember, our best theories about human beings and human cognition are not based on direct observation. They're based on inference to the best explanation, this method that we've talked about today. What this means is, if these novel explanations that we derive from artificial neural networks, if these can better explain our human intelligence and our human capacities, then we will be entirely justified in concluding that we've discovered a new understanding of our own minds. This would be, from a philosopher's perspective, just a truly astounding advance on a set of questions that philosophers have been thinking about, for quite literally millennia. I'd like to conclude with just one last point, which is the following. There's no guarantee in advance that AI is going to be capable of everything that we are. It may well be that some of our capacities, like consciousness or the capacity for sort of creative genius, it may well be that these prove elusive and that maybe we never succeed in replicating them in artificial intelligence. I just want to conclude by saying, from a philosophical perspective, even that would be quite an interesting result, because that might well point to whatever it is about us that is special and that is difficult to replicate. In either case, artificial intelligence promises to offer a sort of a new vantage point on a whole set of questions that us philosophers have really been knocking our heads against for millennia. Thank you for listening.